CLion, a cross-platform IDE for C and C++. Download now.
So, hi everybody. I'm Peter Hrenka. I'm talking about pointer arithmetic. You know, everybody wants to do pointer arithmetic. You know, you shouldn't probably do that for safety reasons. And I have like a different spin on pointer arithmetic. So I say, yeah, pointers, you can like stack pointers. So why just not like start 0? We have a structure that is 0. That's our 0. And if we add one pointer, that's a 1. And we add another pointer, that's 2, like 0, star, star. And like building on that, let's try if we can rebuild like the regular arithmetic with natural numbers and a little bit of C++. And another condition here is not using built-in integers, not using any executable code. So everything is in type space, right? Okay, so let's start with the basics. We want to increment a number. So what do? We just add a pointer to that. If we want to decrement a number, yeah, we would just take the pointer out of that. And so let's say for 0, we should be really careful because that we don't have negative numbers. So we delete this function here, right? Actually, we don't need a template here. Who has fact-checked the slides? Okay, so very easy. We can just add that. And because we want to have good quality, we write tests for that. The API is a little bit tricky because we have to use Deckel type all the time. We cannot just execute the function. We have to call check with the same type, and we can say, okay, if we increment 0, we get 1. If we increment 1, we get 2, and so forth. So we can also build addition. So it's a very similar trick. We don't have to use increment. So basically, we just can check on the left-hand side if there's a pointer. We kind of shift it to the right-hand side of the addition, and we just keep on doing that recursively until we get on the left-hand side. We get a 0, and then we know the result is on the right-hand side, and we're done. And we write tests. And yeah, we have some more helper variables types. Sorry, it's just types. We're totally in type space. We just write the tests here for addition. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 2 plus 2 is 4. Okay? Yeah, okay. Now, multiplication. It's a bit more tricky, and I'm not sure that's the only way or the best way, but I think that's a neat trick, actually. We need a helper function. So what we have is like an accumulator where we put like the sum into that, accumulate the result. And here the trick is, of course, on the left-hand side, we have like a star, which is +1. You have to think it's like +1. And for this +1, we call it recursively, we subtract 1, and instead we add the right-hand side to the accumulator. We keep on doing that until the multiplication ends up with the 0. On the left-hand side is 0. Then we return the accumulator. And the regular multiplication function, we just call the helper, and we have to initialize it with 0 to be correct. Some more tests here. Okay, let's check. 0 times 0 is 0. 0 times 1 is still 0. 0 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. 2 times 1 is 2. And 2 times 2 is 4. Okay, power function. It's basically, it seems intimidating, but basically it's still the same multiplication. We have just like to recurse on the exponent. We initialize with 1 instead of 0, and we just subtract every time. Every time we subtract, we multiply, and here we go, right? Some special handling is needed, of course, for the 0, because like 0 times x is 0, and x times x to the power of 0 is 1, okay? And we don't want to think about 0 to the power of 0, so we delete it. And so we have some tests. We need some more, like a helper type. We defined 8, and of course we check the handles stuff. 0 to the power of 1 is 0. 2 to the power of 0 is 1. 1 to the power of 1 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. And this, you can calculate the other one. So 30 seconds, last slide. So, but why? Why do it? Okay, we do what we must because we can, of course, right? And it's a great stress test for compilers. Try to put a bigger number, it will crash, certainly. So if you think that your compiler is lying to you or your hardware is lying to you, This is like a compile time only implementation of the integers. You can compare with that. And of course, it's a header order compile time arithmetic, and you can do compile time crypto with RSA with that. And this is my last slide. So what next?
Peter is a very twisted man, and he deserved to be pushed off the stage for that. Don't try this at home, kids.